Good morning. This recording is for Algebra 1, Chapter 8, Lesson 7, Factoring Special Cases. So if you remember from 2 lessons ago, we talked about multiplying special cases. We're now going in reverse because like all good things in science and nature, if you can go one way, you can go the other way as well. All right? So you can either factor using the last method, which we talked about in the last lesson, or you can recognize a perfect square trinomial and then factor quickly. Now, to recognize the perfect square trinomials, you just need to double check that the math's correct. As long as you can recognize that A is a perfect square and B is a perfect square, and that whatever A was times B times 2 is the center term or the center nomial, you will realize that it will allow you to just backtrack a little. What's the square root of A squared? Well, it's A, and the square root of B is B, and there you go. You have your factored answer. Okay, so let's go ahead and take a look. And again, we're just going backwards from lesson 4 of chapter 8. Okay, so here's the steps. How to identify a perfect square trinomial. First and last terms, in this case 4x squared and 9, can both be written as the products of identical factors. So that would be 2x and 3. 2x times 2x is 4x squared, and 3 times 3 is 9. There you go. So that's part 1. Part 2 is, can the center term be written as 2 times a and b? So is the 2 squared from there, in there? Yeah, well, there we go. And the 3. So that means that this is a perfect square. All right, so this is a perfect square trinomial, which means it should fit into a perfect square special case scenario. So there we go. Now actually, so again, there we go. So it's A plus B times A plus B, because both of them are being added. So there you go. So you have 2x plus 3 squared. All right. So again, if you figure out that the first term is a perfect square and the second is a perfect square, and the center is 2 times the first square times the third square, you're going to get the perfect square special case scenario. Okay. So, FOIL or multiply special cases to check your answers. All right, and that will double check that you've gotten the right thing. So if you do 2 squared plus 3, or 2 plus 3 squared, you're going to get this original answer back out, and you'll know that things are good. Okay, so factoring a perfect square trinomial where A, the first term, does not have a coefficient. It's basically 1. Go ahead and talk about it. So go ahead and see the Algebra 1 notes for more Chapter 8 examples. Just go do a search in Google Drive for Algebra 1 notes, and you'll see that it's split up by chapters, and that can actually be a study guide. All right? So number 1, we have n squared plus 16n plus 64. N squared, perfect square. 64, perfect square. Now, is 16n one of the n's times 8 times 2? Well, let's see. It does, because 2 times 8 is 16 times n is 16n, which means this is a perfect square, which means the answer is just the n from the first term and the 8 from the second term squared. There you go. And again, you can check with foiling. All right. Now, the difference between the first two is that there is a plus n squared plus 16n, and here we have n squared minus 16n. And if you remember from your special cases, it just means that your special case has a negative. Now, because 64 is positive and the 16 is negative, that means that the 8 has to be negative, which is again applying to my special case all the way back here. So again, if this is negative, right there, and this is positive, it's going to give me this for positive and that for negative. Okay? So again, that's where the whole negative positive thing comes from. All right, back where we were. There we go. All right, so again, these are going to be negative 8s for the 64 squared because we need that negative 16 to come up. So there we go. So we have negative 8 times n, which is negative 8n, and then I have to multiply 2 because that's the way the center term works. So there you go, and you can check by foiling. All right, so factoring a perfect square where a with a as in a in ax squared plus bx plus c is not equal 1. The coefficient is not 1. So even if it has a coefficient, look to see if it is still a perfect square. All right, so if we have 9g squared minus 12g plus 4, 9g squared is still a perfect square. It's 3g times 3g. So it actually doesn't matter that the coefficient isn't 1. And again, this depending on when you're listening to this, I had somebody ask me before and I wanted to bring this up, but whatever. Okay, so, and then 4 is still a perfect square, and the center term is still the first perfect square times the second perfect square, and we know that both of these twos must be negative because, oh wow, this is a long part of it. Because, actually, let's go ahead and pause that right there. So we know that both of these twos must be negative because we need a negative 12g. All right? They have to be negative. This has to go on, folks. 4 is positive, and that's because it's a negative 2 times a negative 2, because a negative 2 squared is still positive 4. But we need the negative 2 to make that center term, negative 12, negative. All right? Because this 2 here that we always multiply to determine if it's a perfect square trinomial is always going to be a positive 2. It's never going to be a negative 2. So that's why you have to keep track of this. All right. So the negative 12g works, so that means it's going to be the first term times the second, or minus the second term, or plus negative 2, and it's just going to be squared because it's a perfect square trinomial. And again, check with FOIL or multiplying special cases to make sure that your answer is correct. All right, next problem. We have 4t squared plus 36t plus 81. 4t squared is a perfect square. 2t times 2t. 81 is also a perfect square. Now let's see if the middle term works out. We have 36t, so we want 2t times 9 times 2. Well, guess what? It works. We get 36t, which means my special case is 2t plus 9 squared. All right, so factoring the difference of squares, where a is 1. So again, a in this case is actually m, and it actually has a coefficient of 1. There's nothing being multiplied by m squared. Well, let's go ahead and take a look. If the first, because it's always m minus b, so if a minus b, a minus b. So if a is a perfect square and b is a perfect square, well then you just go and hightail it back to the original special case. So m times m minus 10 times 10, pull out the m's, pull out the 10's, and because it's a difference, because this is subtraction, that's how we know it's a difference right there. Okay? All right, so let's take a look at the next one. Now, if a is not 1, all right, if we have a coefficient, if the coefficient in this case is 25, well, 25x squared is just 5x times 5x. 64 is just 8 times 8. So it's just going to be 5x plus 8 times 5x minus 8. And that's your final answer, guys. This is just something to help you skip a lot of steps. So you have to sit there and go, okay, well, what is it? Oh, gosh. Can't think of two numbers that multiply together to give me 64, but add up to give me 0. Because, again, this place, it's 0. The bx in this situation for this 25x squared minus 64 is 0. So, yeah, it's a little crazy. But in this case, it would be 8 times negative 8, which gives you the negative 64, but then 8 plus negative 8 is 0. So that's also how it works. Okay, so check again with FOIL or multiplying special cases. I dare you, it works. Prove me wrong. All right, we have another one. Something that might not look like a difference of squares at first, but if you factor out a common factor, then do the difference of squares, it's going to look a lot better, okay? So the cool thing is I can pull a 3 out of this. So this is, at first, not a perfect square. But then again, if I factor out, then look at what shows up, we're going to get this figured out. I already said it's just an artifact. Okay, so 3c squared is the same as 3 times c squared. 775 is 3 times 5 times 5. So if I pull out a 3, I'm going to get 3 times c squared minus 25, because that's what's left over. But guess what, guys? This is now a perfect square. C times c and 5 times 5. That's going to give me my difference of squares. right there. Yep. And then I'm going to have c plus 5 times c minus 5. But don't forget the 3. If you pull something out at the beginning, it still needs to be in your answer at the end. All right. So check by FOIL and then distribute the 3. Okay? So 25k squared minus 7. Pull out the 7. It's a difference of squares. And just remember that because you pulled out the 7, you still need that placeholder. So there's a 1 there, all right? I pulled the 7 out. There's a 1 there. And remember that 1 is a perfect square. And don't you forget it. Just because you have a 1 there doesn't mean you can stop. It's a perfect square. So use that to your advantage. So 4k squared is 2k times 2k. 1 is 1 times 1. Duh. And then there you go. You have your difference of perfect squares, and you're done. All right, guys, I'm done talking at you. Bye.